Recently, CEO Elon Musk had implicitly revealed that SpaceX had conducted the first test of Starship's new Raptor 2 engine. Besides kicking off integrated static fire testing of a refined, operationalized version of Raptor, the first prototype may have briefly become the most powerful engine of its kind ever tested. Let's check out more about SpaceX's incredible new Raptor engines. Number 6. Introducing the RVac. A few days ago, it was reported that SpaceX completed a full-duration test fire of the Raptor vacuum engine at its rocket development facility in McGregor, Texas. The Raptor vacuum engine is specifically optimized to help propel SpaceX's Starship rocket through the vacuum of space. The RVac, as the company has dubbed it, is an absolute monster. The ship, designed to send the first humans to Mars and establish a city, is currently undergoing testing at SpaceX's facilities in Texas. This is the first time that the Starship has fired a vacuum variant of its Raptor engine, specifically optimized to propel the rocket through the depths of space. Musk is believed to have a mission to establish a city of 1 million people on Mars by 2050. To achieve this goal, Musk has calculated that SpaceX will need to send around 1 million tons of cargo to the planet. The Starship, when paired with the Super Heavy booster, is designed to transport around 100 tons to Mars at a time, which means that SpaceX will need to host around 10,000 flights to Mars. The vacuum variant of the Raptor engine is key to achieving this. The Super Heavy booster, which lifts the Starship away from Earth, is expected to feature 33 Raptor engines optimized for use in the atmosphere at sea level. The Starship, which detaches from the Super Heavy to complete the journey, will feature 3 sea level and 3 vacuum Raptor engines. Number 5. The new size. The vacuum variant of the Raptor engine is optimized to better propel the rocket as it moves through space. A previous size comparison by SpaceX also showed that it's not just a minor tweak. The vacuum variant is gargantuan. So why is it so much bigger? Because of the difference in pressure out in space. NASA explains that in the simplest terms, a rocket engine sends out hot gases through a nozzle to produce thrust. The design is based on Newton's third law. For every action, there is an equal and opposite reaction. Gas pushes out through the nozzle, and the engine gets pushed forward in return. The Mars Society of Canada, which advocates for exploring the planet with rockets like Starship, explains that making the nozzle larger forces the gas out into a wider area and increases the thrust. The problem is when the gas expands out so much that the pressure is lower than the surrounding atmosphere, the atmosphere then pinches the gas and pushes it away from the nozzle walls. Number 4. Components. The Raptor engine is powered by subcooled liquid methane and subcooled liquid oxygen in a full-flow stage combustion cycle, a departure from the simpler open-cycle gas generator system and LOX kerosene propellants that current Merlin engines use. The RS-25, first used on the Space Shuttle, uses a simpler form of a staged combustion cycle, as do several Russian rocket engines, including the RD-180 and the RD-191. The Raptor engine is designed for the use of deep cryogenic propellants, fluids cooled to near their freezing points, rather than using the cryopropellants at their boiling points that is more typical for cryogenic rocket engines. The use of subcooled propellants increases propellant density to allow more propellant mass to be stored with the vehicle's tanks. Engine performance has also increased with subcooled propellants. Specific impulse is increased, and the risk of cavitation at inputs to the turbopumps is reduced due to the higher propellant fuel mass flow rate per unit of power generated. Engine ignition for all Raptor engines, both on the pad and in the air, is handled by dual redundant spark plug lit torch igniters, eliminating the need for a dedicated consumable igniter fluid as used on Merlin. Raptor has been claimed to be able to deliver long life and more benign turbine environments. Specifically, Raptor utilizes a full-flow stage combustion cycle where all the oxygen will power an oxygen turbopump, and all the fuel will power a methane turbopump. Both streams, oxidizer and fuel, will be mixed completely in the gas phase before they enter the combustion chamber. Number 3. Expanded nozzles. Rocket engines have many parts, of course, but the largest and most prominent is the nozzle, which channels the flow of exhaust gas. This exhaust originates in the combustion chamber where oxidizer and propellant combust. This exhaust gas is then pushed through a narrow opening called a throat to accelerate it. Now, traveling supersonic, the exhaust expands as it enters the nozzle, where the longer and wider the nozzle is, the faster the exhaust moves. Faster gas coming out of a rocket engine is good because it delivers more thrust. More thrust means your rocket can lift more mass. An expanded nozzle therefore means better performance. However, we don't see all rocket engines having giant nozzles, do we? That is because of a phenomenon known as flow separation, which happens when the flow of gas inside an engine separates from the nozzle walls. This can induce turbulence and vibrations. In a worst-case scenario, it could result in the engine blowing itself up. There is no absolute value for when this occurs, but the risk of flow separation increases when the pressure of exhaust exiting the nozzle falls below 50% of the ambient pressure. Primarily, the vacuum variant of the Raptor engine is optimized to better propel the rocket as it moves through space. Number 2. Fired twice in an hour. SpaceX is midway through a slow-going licensing process with the Federal Aviation Administration to determine whether the Elon Musk-owned firm will be allowed to launch its Starship into orbit from its facilities at Boca Chica, Texas. But that doesn't mean it can't continue to push forward. SpaceX debuted a video of Raptor vacuum engine equipped on a Starship prototype and what became the first integrated test fire of the space-worthy propulsion system. The Raptor vacuum is essentially a rocket engine designed specifically for maneuvering in space, like a modification of the conventional Raptor engines that will lift the Super Heavy booster and the Starship stacked above it. Beyond Earth's atmosphere, the vacuum engines feature extra-wide nozzles and can perform more efficiently in the drastically challenging environment of space, which is very different than the atmospheric Raptor engines. When it's ready, Starship is slated for 3 RVACs, in addition to 3 additional conventional Raptor engines for missions that will take it to the deepest reaches of the solar system. The first static fire of the RVAC engines happened at the tail end of a 7-hour test window, according to a report. This is when Starship S-20 fired its engines, but only for what's called a pre-burner test, which is where only the first half of a static fire test takes place, cutting off before full ignition kicks in. But on October 21st at roughly 8:16 p.m. Eastern Standard Time, the first full static test fired up. A little more than an hour later, the Raptor vacuum performed a second test fire, but this time it fired both the RVAC and the Raptor center engines. This represented 2 firsts. The first time both types of rockets were fired at once, and the first time 2 static test fires were done in such a short period of time. Number 1. Present status. Musk also revealed that the first orbital launch for the next-gen spacecraft could take place as early as November, if the company can gain the necessary approvals from the Federal Aviation Administration. SpaceX currently has more than 100 Raptor engines at bay at the space exploration company, announced last week. In addition to this, SpaceX is preparing to start a new Raptor engine factory in McGregor to ramp up the production even more than the current rate of 1 Raptor produced every 48 hours. So there is no short supply of Raptor engines to be installed in both the Starship and the Super Heavy rocket booster. Super Heavy is the first stage of the entire Starship spaceship, ultimately aiming for the Mars mission. Now, how did SpaceX complete the test firing of the vacuum-optimized engine without destroying it? Responding to this question, Musk said on Twitter that the company solved the problem by building the Raptor engine to produce a very high chamber pressure. The engine is also not yet fully optimized for a vacuum, so there was enough margin to prevent flow separation from destabilizing it. This allowed SpaceX to complete its test without anything blowing up. So, what do you think? Is SpaceX's Raptor the most advanced rocket engine ever built? How different is it from the other rocket engines? Let us know in the comments below. We hope you enjoyed watching the video as much as we enjoyed bringing it for you.